be sure to get them in order. So we start with a line, y equals x, and you get a vertical shift up 6 units. And I want you to say vertical shift. Not moves up, not up. You start with your quadratic. Square, if you call it a squaring function, probably even better. And I should know better than to reset this. Cubing function, we have a negative sign here. This gives us a reflection. It's a reflection in your x-axis because your y is negating. Stop me if you have a question. Okay. Square root function, anything under the square root, inside the absolute value, inside the parentheses, is a horizontal shift. So I want to see horizontal. This is wrong. Theirs is wrong on this one. This is a quadratic or a squaring function by a factor of what? 9. By a factor of 9. And what is it? What do we call it? A vertical stretch. If you call it a horizontal, it'll be a horizontal shrink by 1/9. You can't possibly have a shrink by a larger factor. And they forgot to, I can't change their answer sheet because it's a PDF file. So we're just going to call this a vertical stretch by a factor of 9. This turns out to be 9x squared. If you even put this in your calculator on the quadratics, it makes it a little easier because you know your quadratic, your squaring function, has a 1, 1 here. See where that 1 is going. This one went to 9 by a factor of 9. So you could say, what times 1 gives you 9? There's your factor. Okay. This one, your squaring function is your parent graph. Inside the parentheses first, go to the x. What's going to happen to the x? It's going to subtract 4. So this is the one it's going to hit first. It's going to go the opposite way, horizontal shift to the right 4 units. Make sure I see horizontal shift. Then up here, what does the +6 do? Vertical shift up 6 units. Good. This is your, they call it a reciprocal, we call it a rational, whatever you'd like to call it, we called it irrational. It left it there, it just took a vertical shift down 3. That's the one that has the asymptote in it. It has to have an asymptote because x cannot be 0. So that's the one that has the asymptote. Stop me if you have any questions, guys. Okay, number 8, square root function. And we have a vertical stretch by a factor of 3. Absolute value. Inside the absolute value is a horizontal movement, opposite way. Horizontal shift to the right 4 units, and then a vertical shift down 8 units. Usually the order matters when you have a reflection in here. Because if you think about it, if you take something and you reflect it and then you shift it, it makes a big difference. Here's a line. It's just a linear function, the line. And it had a factor out here. So this is a vertical shrink. They called it a compression, which is fine, by a factor of 1/2. A shrink has to have a fractional factor. A stretch has to have a whole number. Here's your cube root. Your cube root, your cubing function, is your parent graph. Inside, underneath the radical, moves the opposite way horizontally, left 2 units. Good so far? Questions? Everybody remember these? Yeah, good job. Okay, go to the X first. It's going to do this one first. It's going to take a horizontal shift which way? Right? 1 unit. Then it's going to come out here and hit the factor of 3. It's going to multiply by 3. And what's that going to do to us? A vertical stretch by a factor of 3. Then it's going to come out, and what's the plus 1 going to do? Vertical shift, factor of 1. Vertical shift by 1 unit.
Don't you have to write it?
Yeah, they didn't write it in the right order. It actually will work fine. The only time you have a problem is, say, a reflection. If you have so if you do your reflection first, a reflection, so your y is going to change, and then you add 2, you'll be over here, right? If you do this first, if you add 2, you'll be up here. Where will your reflection be? Down here. So it really only makes a difference in the reflection. The rest of it works out okay. Excuse me. You have a cubing function. Go to the parentheses first. This gives you a, what kind of shift? Horizontal, which way? Left, 9 units. Good. Everybody understand that this goes the opposite way? It's kind of like your circle formula. When you see your circle formula, it always was the opposite way. So if you did this, and this was your circle, what would your center be? 1, -2. So now does the transformations make sense? Because if it was at the 0, 0, now your center is going to be at the 1, -2. It falls anytime you have the parentheses there, it's going the opposite way because of that formula. Excuse me. So now you come out, do the 2 first. Okay. What does the 2 do? Vertical stretch. What does the negative do? Reflection where? Reflection in the x-axis. Then you come out. What does the -4 do? Vertical shift down 4 units. Okay. This is your reciprocal function right here. So this would be like the parentheses. So what is the 5 doing? Horizontal shift which way? Left 5 units. And then a vertical shift down 2 units. Okay, make sense? You're going to have to do this part on your test without your calculator, the transformations. It's nice to be able to confirm it on your calculator when you see some weird things, but most of the time you're going to do this without your calculator. Algebra 2 does a lot, well actually geometry does more of this probably, right? You probably did this in geometry. Okay. Geometry usually gives you a function, and algebra 2 usually gives you a function right on your paper, and then you do your transformations off of that. If you find it easier to do it off the points, go off the points. If you have a vertical shift, does it affect your x or your y? Your y. So if it helps you, just add 2 under all of these. If you're a nice spatial person, just go up 2 and do it that way. Okay? It kind of gives you a good feel for what your transformation is doing. This negative does not affect your x, it affects your y. So y goes from positive to negative. It's a reflection in your y in your x-axis. Your y is going to negate. So in every case here, just multiply your y by a -1 and negate it. Just take the opposite and draw your new point. And there it is. Stop me if you have any questions. You guys did these before, right? Yeah. Probably quite a bit, right? Okay. All right. So they're giving you the same thing and asking you inside horizontal shift to the right 2 units. Is it going to change your x or your y? horizontal shift changes your x or your y? Your x. So if it helps you, x plus 2. And make your new points. Just move everything 2 over. This guy, again a horizontal shift, left 3. So if it's easier, subtract 3. And plot your points. Or just take the original. Everything always goes off the original. And move it left 3 units. Okay. Paragraphs, you had to identify them and write the equation for the new one. Did I write on yours, find the domain and the range? No, of course not. Alright, find the domain, we'll find the domain and the range. So your basic squaring function, what is the domain and the range of this guy? All real numbers. And range is what? 0 to infinity. We can't have a negative because anything squared is always going to give you a positive. And always check your 0. You can have a 0 for this. So this guy went down, and you kind of have to use the graph to see it. It went down 1 unit. There's your minus 1. Did you come up with this equation? You had to come up with this. So sometimes, because I took it out of the book, I don't put the whole thing on mine. Obviously, I didn't put that on yours. Okay, so you're going to go down 1 unit. So does it affect the x or the y? Vertical. The y. So come to the y and just drop it by 1. So the only thing that's going to change is the range. Okay. You had an absolute value here, an absolute value function. What's the domain for absolute value? Same as this guy, right? Same range. We can't have a negative. So this took a horizontal shift to the left 2. Left 2 gives us a plus 2. So it affects the domain, but our domain is all real numbers. Good? Sometimes it's a little different seeing it in the graph than it is seeing it with the steps. A square root function, this has a reflection and a plus 1. It'll reflect it first, and then it'll jump it up 1. So let's hit this domain and range. What's the domain for the square root function? 0 to infinity. Good. What's the range? Yeah, 0 to infinity. What will the reflection do? What will it affect, the domain or the range, if we do a reflection in the x-axis? The range, right? The domain is still from 0 to infinity, but it will affect this. So now this new range says negative infinity to 0. Well, yeah, we're going to add the 1. Yeah, I just took it step by step. So now you're going to jump up 1. So this is going to change to plus 1. Okay, so there's your new range. Your domain didn't change. Nothing affected your domain. Okay, cubing function. Cubing functions are easy. The domain and the range are all real numbers. Okay, so you've got some kind of a reverse here. So you've got a reflection, and you have some kind of a shift, and it moves 1 up. So you've got a reflection, and do you need the parentheses? Could you do it the other way? Is it reflected in the y or reflected in the x? Does that matter? Yes, no? No? Okay. And the last guys, And you have an absolute value with the negation. So that gives you a reflection in your x-axis. What changes, the domain or the range? Range. So your new range becomes what? Oops. I don't know what I did. We're back. So this new range becomes what? Negative infinity to 0. But a reflection in your y-axis keeps that graph the same. This guy, a rational, did you get the picture? Is that what you got? The picture? Okay. A reflection in your y-axis. Could it be a reflection in your x-axis? Same. And cubing function. What does this do? Shrink which way? Vertical shrink by a factor of 1/4. Make sure you give me by the factors. I need to see by factors. If you're shrinking, your factor cannot be greater than 1. If you're stretching, your factor cannot be less than 1. If there's a negative out there, you can't shrink a negative or stretch a negative. That's a reflection. Make sure you separate those two. Okay. And then this was the other set of homeworks that you guys had. Did we do it this way?
I think you always come back to. Oh, I just did the first. I just did the first and the last, like the final one.
Oh, you just did the first and the last one? Okay. All right. You did it without your calculator? Yeah. Okay, as long as you did it without your calculator. I have to say, coming from Common Core, I'm sure my first group through Common Core, you guys are much, much better with transformations. In the past, it's always been such a struggle with transformations. But you guys are much, much better with transformations. I see a big difference right there. So just remember order of operations. When you give this to me, this one comes first. Horizontal shift, left 5 units. Then it comes outside the parentheses. This is a reflection in the x-axis. It's not next to your x, it's going to affect your y. If you would rather take this one and move it over here plus 2, that is fine. The last thing it's going to do is up 2 units, a vertical shift up 2 units. What's the original domain for your squaring function? What's that domain? All real numbers. And the range? God bless you. Good. So here's your final one. Does the domain change? No. No. What's the one thing? Well, there's actually 2 things that affected your range. A reflection. Good. So the reflection said negative infinity to 0. And then what? Vertical shift up 2. Right? A vertical shift up 2 affected it. So if I ask you for your range and your domain, start with what you have, start with your parent, and then see which transformations affect the x, which transformations affect the y. And you don't have to go in order the way I did. If you give me first and last, that's fine, as long as I get each individual step and you're able to give me domain and range. Good? Okay. again, squaring, we start inside. This gives you a horizontal shift right for units. We come outside, we hit the 2. What does the 2 do? Vertical stretch. So how do I exactly say a vertical stretch? I just make it a little bit narrower. Remember, you're sketching. I don't want you to pick up a calculator. But if your original graph went like this, you're stretched by a factor of 2. If this is 1, 1, this is 1, 2. So it's just stretching. It's the same 0. It's just stretching up a little bit. Yes.
No matter the order when, like, that we list the...
Yes. These have to be in the order of operations that you find these. It has to be. This one doesn't really affect it because there's no reflection, but a reflection will affect it. So start order of operations. Start here, come out. If you'd rather put this guy over here, that's usually what we look at. What the +3 is over there. And that's a vertical shift up. Okay? I need these laid out. If you want to give me first and last, and you can do the rest in your head, that's fine, but you'll have no calculator to do this part. Okay? Start inside the parentheses. That's a horizontal shift right 2. Cubing. Which is affected on cubing, the domain or the range? Neither, because they're both all real numbers. So we shift right 2 units, and then we do a vertical stretch by a factor of 3. Hold it up slightly. And again, you're sketching, so the best you can with the sketch. Cubing again. Horizontal shift to the right 1 unit. And what does that +2 do? Vertical shift up 2 units. If it's hard to show the vertical shift, try to take this point and move that point up. Absolute value. You have a horizontal shift to the right 1. Do these 2 separate. You have a vertical stretch by a factor of 2, and then you have a reflection in your x-axis. You can have a vertical stretch by a factor of -2. And then you're going to shift 4 units down. Vertical shift. Good. If we did domain and range for this, originally your domain is all real numbers. So is your domain going to be affected at all? No. Originally your range is 0 to infinity. Which 2 things are going to affect your range? Reflection. And then, good. You guys are good. Uh-huh. Well, yeah, you can absolutely say that in 2, as long as you say them separately. Mm-hmm. If you bring this down to 3, and then this would be 4, that would be even better. As long as just don't put a -2 in there as a stretch. That doesn't bother it. Yeah, that part doesn't bother it. And when you sketch this, just remember that a stretch gives you a narrower graph. A shrink gives you a wider graph. So, like if you're graphing this, you're going to see it on your calculator, but since you don't have a calculator, just kind of make sure it's a little narrower when you do a stretch, a little wider when you do a shrink. It's kind of the opposite way. And your last guy, a square root function. So you're going to shift 3 units to the left. you're going to do a vertical shrink by a factor of 1/2. And then you're going to do a reflection. And lastly, a shift, a vertical shift down. And you could do those in 4 steps as well. As long as, just don't give me this as negative 1/2. Keep those separate. You can keep them together like this, or you can write them in 2 different steps. Usually I do write them in 2 different steps.